Hello, welcome to class. Today we are looking at limits of a function. Limits of a function. So what do we mean by limit of a function? The limit of a function is the value of the function when the function has been simplified in its simplest form. Wow, that's a whole lot of story. Let me explain like this. This is the symbol for limit. I write x tends to 2. This is limit. I'll explain what that means. If I write x equals to 2, this is an equation. They are two different things, they are not the same thing. Let's say, for example, let's say function f of x is given by x plus 3, x minus 2 over x minus 2. So number one, let's evaluate x equals to 2. If I want to evaluate x equals to 2, that means that anywhere I see x, I put 2. That's an equation. I can still do that. 2 plus 3 bracket 2 over 2, 2 minus 2, like that. But if I want to do limit x tends to 2, this is limit. That does not work like that. I won't substitute the value of x immediately. I have to simplify to the lowest form. That's what I mean by it has to be simplified in the simplest form before I can substitute the value of x. So in this case, I can see that there's x minus 2 here, there's x minus 2 here, so I cancel out. So I'll be left with what? X plus 3. So x plus 3 is the simplest form. At this point, I can now substitute my value of x. This is now 2 plus 3. And that will give me what? 5. So this is the limit of this function as x tends to 2. So that's why we said the limit of the function is the value of the function when the function has been simplified in the simplest form. So that before you can substitute the value of x for limit, you must check if you can simplify that function. And you can simplify the function in two ways. Is that by using factorization or by dividing all two by the highest power. I want to explain this by one of the examples. We call that limit at infinity. And please take note of this. The limit of a function can never be undefined. What is mean by undefined? Undefined is when your denominator is 0. E.g., if I have 2 over 0, that's undefined. If I have 5 over 0, that's undefined. If I have 7 over 0, that's undefined. So anytime you substitute the value of x to the function and is giving you the denominator as 0, it's giving undefined, then you know that you have to simplify first before substituting. So you cannot have undefined, number one, and you cannot have indeterminate forms. What do I mean by indeterminate form? Something like 0 over 0 is indeterminate. You cannot have infinity over infinity. So anytime you substitute value directly and you get 0 over 0, then you should know that it means that expression can be simplified. That is the idea of limits. Let's go to some examples. Example 1. Evaluate 3x squared plus 5x. I'll look at it. The first thing you check when you are doing limits is that you ask yourself if you can simplify the function or the expression. This is 3x squared plus 5x. There is no way I can simplify these expressions again. So I will just substitute the value of x because this is x tends to 2. So my answer here will be 3 bracket 2 squared plus 5 bracket 2. And that will give me 3 bracket 4 plus 10. And that gives us what? That gives us 12 plus 10. So the answer here is 22. So the limit of x tends to 2 for this function is 22. Excuse me. Let's go to example 2. For example 2, I have cos x over 2 limit x tends to 0. I'll ask myself, this expression here, this function cos x over x minus 2, can it be simplified to the simplest form? Let's check. Is there a way I can reduce cos x to be like x minus 2? Or is there a way I can change x minus 2 to be like cos x? The answer is actually no. Because as it is now, it's already simplified. So when your function is already simplified, it's already in simplified form, what you do at that point is that you can substitute the value of x directly. So at this point, I can substitute the value of x directly. So here we have, anywhere I see x, put 0 because this x tends to 0. So this will give me cos 0 over 0 minus 2. And that will give me cos 0 is 1. 0 minus 2 is minus 2. So my final answer is minus 1 over 2. So the limit of this function is minus 1 over 2. Let's move on to the next example. Example 3. We are looking for lim s tends to 3 for s squared minus 4s plus 3 over s squared minus 9. Now this is a quadratic expression, so I will see if I can simplify this. Obviously, I can simplify this. If I have s squared minus 4x plus 3, how will I simplify this? Don't forget, you have explained this before. We think of two numbers that when you multiply them, if you give a product of plus 3 and the sum of minus 4. So that kind of numbers are, they are what? Kind of number they are minus 3 minus 1. Minus 3 minus 1 will give plus 3. Then minus 3 plus minus 1 will give minus 4. So if I simplify this, I will have this expression. This I will have brackets, close brackets, brackets, close brackets, then over. Now the what is called difference of two squares. Okay, let me finish this one first. So this expression here will give me this x squared minus 4x plus 2 will give me x. So the answers are what? Minus 3, minus 1. Alright. Now this, if I have x squared minus 9, this will also give me x squared minus 3 squared. So that means I have two squares and I have minus in between them. Then what is called difference of two squares? Let me remind you. Recall that a squared minus b squared to give us a plus b, a minus b. We call this concept difference of two squares. We call it difference of two squares. Difference of two squares. So if I go back, x squared minus 9 would have given me x squared minus 3 squared, and that will have given what? X plus 3, x minus 3. If I use this formula here. So let's go. So I have x plus 3, x minus 3. So let's see. There's x minus 3 here, there's x minus 3 here. So this cancels this. So I'll be left with x minus 1 over x plus 3. So at this point now I can substitute the value for the limit. The value of the limit is x tends to 3, so that will give me 3 minus 1 over 3 plus 3, and that will give me 2 over 6, and that will give us the lowest term. That will give me 1 over 3. So that's my answer. So let's go to example 4. Let's go to example 4. So this is another quadratic expression. Evaluate lim x tends to 4, x squared minus 9x plus 20 over x squared minus 3x minus 4. So if I factorize this using product and sum, the first line of this will give me brackets, 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 brackets over these two brackets, 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 brackets. So if I use the idea of product of plus 20, sum of minus 9, I have x squared here, so I have x. So if I factorize this, I have minus 4, minus 5. And this will give me x. If I factorize this, I will have plus 1 minus 4. More like think of two numbers that when you multiply, you get product of minus 4 and the sum of minus 2. I've explained quadratic expression in one of our videos, so you can check our page to see the shortcut for factorizing a quadratic expression. So at this point, you can see that x minus 4 is common. So x minus 4 is there, x minus 4 is there. So we are going to be left with x minus 5 over x plus 1. So at this point, since we have simplified to the simplest form, we can substitute our value of x. So our value of x in this case is 4. So that will give me 4 minus 5 over 4 plus 1. And that gives us minus 1 over 5. Minus 1 over 5. So let's go to example 5. Example 5, the same idea, just that this is cubical. Evaluate lim x tends to 3 x cubed plus x squared minus 12x over x squared. So the first thing here is that I will factorize the numerator. In the numerator, I can see that x is common. X is here, x is here, x is here. So I'll bring it out. So that will give me x bracket x squared plus x minus 12. That will, if I factorize the numerator, this is what I have. Divided by, this is a difference of 2 squared. Don't forget, if we have a squared minus b squared, to give you a plus b, a minus b. So we have x squared minus 9 to give you x squared minus 3 squared. And that will give you x plus 3, x minus 3. So this is x plus 3, x minus 3. So I will now see if I can factorize the quadratic in the bracket here. So this will give me x bracket. If I factorize this, I will have x plus 4 bracket x minus 3 divided by x plus 3 bracket x minus 3. So we can cancel out at this point. So at this point, we can cancel out this, cancel this. So I'll be left with x bracket x plus 4 over x plus 3. So we can put our limit now. Our limit is 3. So that's 3 bracket 3 plus 4 over 3 plus 3. and that will have given me 3 times 7 over 6, and that will give me 7 over 2. So that is just the answer. So this will have been 3L1, 3L2. So 7 over 2. Alright, so with this, these are our WAEC questions on limits. So that I put them together so that you can understand the concept of limit very well. Let's look at example 6. Example 6, evaluate lim x tends to 1 minus x over x squared minus 3x plus 2. So the first thing we do is that we are going to rewrite. If I have, I'm going to rewrite. So if I have 1 minus x, 1 minus x is the same as saying minus x plus 1. If I rearrange it, then what is common? If I leave the minus out, then I say minus bracket x minus 1. I'll still get all of this back. Then what do you have done? I have x squared minus 3x plus 2. If I factorize this using the concept of product of plus 2 and sum of minus 3, I should have something like this. Product of plus 2, since I have x squared here, so I have x. Think of two numbers that when you multiply you get plus 2, and when you add them together you get minus 3. So that should give me minus 2 minus 1. That's the product of plus 2 and sum of minus 3. So if I go back to the question, so where will have changed to what now? Minus, all of these will have changed to minus open the bracket x minus 1 over the denominator will have changed to x minus 2 open the bracket x minus 1. So we can cancel out a common factor. So this can cancel out this. So I'll be left with minus 1 over x minus 2. So I can take my limit now. What's the limit? Limit is as x tends to 1. So that will be minus 1 over 1 minus 2. And that was like minus 1 over minus 1. And our answer will be what? Minus 1 over minus 1. Our answer will be 1. This cancel this. Okay, let's go to example 7. So you can always rewind and check the way you have solved it. Example 7 says that evaluate limits x cubed plus 8 over x plus 2. This is another WAEC question in further mathematics. So what you are going to do is that you are going to factorize x cubed plus 8. X cubed plus 8 is same as saying x cubed plus 2 cubed. So here we have 2 cubed, but in between them we have plus. Another name for plus is sum. So there's what is called sum of 2 cubed. Let me give you the formula for sum of 2 cubed. We have sum of 2 cubed, we also have difference of 2 cubed. The formula for sum of 2 cubed is this. Let's give formula. So we have a cubed plus b cubed. The formula is a plus b bracket a squared. If you have plus there, you have plus there. Then this will be opposite side minus ab. This is plus. This is always plus plus b squared. This one is called sum of 2 cubed. Let me give it for difference of 2 cubed. The unit of 2 cubed is a cubed minus b cubed. This will have given us what? A minus b bracket. If you have minus here, you have minus here. This will be a squared. Then this one, is always the opposite side, so it's plus AB. Why this is always plus? The last point is plus plus B squared. So you have to master this formula. So if I want to simplify S cube plus 2 cube now, if you give me, let me use a different so that you can see. S cube plus 2 cube will give me, follow this formula, to give me x plus 2 bracket, because our a is not x, our b is not 2, bracket a squared s squared minus, what's our a now? X, bracket, what's our b now? 2, plus, what's our b now? 2 squared. Just follow this formula. Just follow this. So that will now give us x plus 2 bracket s squared minus 2x plus 4. So that's the factorization of this. So let's apply that for the question. So lim s cube plus 8 we change to, so I will now have, so the s cube plus 8 we change to all of this answer now, bracket x plus 2 bracket s squared minus 2x plus 4 divided by, let's go back to the question, divided by x plus 2, divided by x plus 2. So you can see there's a common factor now. This we can do this. So we are going to be left with what? I'm going to be left with s squared minus 2x plus 4. Let's check, is this factorizable? I don't think so. Product of plus 4 sum of minus 2. I don't think that's factorizable. So leave it like that. So what's the limit value? The limit value is x tends to 2. So x tends to 2. So x tends to 2, that will give us 2 squared minus 2 times 2 plus 4. And that will have been 4 minus 4 plus 4. So our final answer there should be 4. So this cancels this. Our final answer is 4. Let's go to example 8. The example 8 is on difference of two cubes. I put these two examples together so that you be used to it. Example 8 is on difference of two cubes. Example 7 was on sum of two cubes, so that you be used to it. Because you can never tell the one WAEC will give to you. So let's record the formula again. No, this will have changed to s cube minus 3 cube, because 27 is 3 cube. As usual, this is the difference of 2 square. This is s square minus 3 square. So let's record the difference of difference of 2 cube. Let's record difference of 2 cube, a cube minus b cube. The formula is a minus b, a square plus ab plus b square. So therefore s cube minus 3 cube we change to x minus 3, a square, that's s square, plus our a is now x times b is 3 plus b 3 square, 3 square. So that will give us x minus 3, x minus 3, s square plus 3x plus 9. Okay, so that is the factorized form for s cube minus 3. So let's go back to the question. So the question is now, let me use a different thing so that you can see clearly. So question is x cubed minus 27. So x cubed minus 27 is not this now. X cubed minus 27 is now not this. So I will have x minus 3 bracket x squared plus 3x plus 9 divided by all of this, like you know, x squared minus 3 squared. This is difference of 2 squared, so this will have given us x plus 3 x minus 3. We have explained that before. So this is x plus 3 in no particular order, x minus 3. So let's cut out the common factor. Let's cut out the common factor. So the common factor there will have been this, cancel out this. So I'll be left with x squared plus 3x plus 9 over x plus 3. So let's check our limits now. Can I factorize this? I don't know, I don't think so. There's no sum of plus 9 and product of plus 3, so leave it like that. Our limit value is x tends to 3, so let's substitute. So our limit value x tends to 3 squared plus 3 times 3 plus 9 over 3 plus 3. So all of that will give us 3 squared is 9 plus 9 plus 9 all over 6. So that will have given us 27 6. So that is the answer for that. Okay, example 9. Example 9 says that evaluate limit x tends to 1, 2 minus 2x cubed over x 4. So if I factorize the numerator, it will give us 2 brackets 1 minus x cubed over, if I factorize the denominator, I will have s squared all raised to power 2. That will give me s4 minus 1 squared. Actually, if I do 1 square, I'll still get 1. So this is something that's saying 2 bracket. This one can change to 1 cube minus s cube. What is that telling? What is that telling you? That should be telling you difference of 2 cube, because I can adjust this one to be like 1 cube minus s cube. So I'm going to apply difference of 2 cube formula again at this point. So let me write it first. So that will give me s cube minus 1 cube minus s cube divided by, here I want to apply difference of 2 square. I want to treat all of this s square as a square, and I'll treat this one as b. So this become s square plus 1 s square minus 1. So let's go and break this down. So let's recall that what a cube minus b cube, a difference of 2 cube. A cube minus b cube is actually a minus b, a square plus ab plus b square. So if I want to simplify 1 cube minus s cube, it will give me 1 minus x 1 square plus 1 times x then plus s square. And all of that will give me 1 minus x 1 plus x plus s square. So let me keep this. That is what I'll put. I'll come and put that here. Let's see if I can factorize. Look at the denominator. I have s squared plus 1, so I can factorize that. But look at this, the other one, s squared minus 1. I can easily factorize s squared minus 1. S squared minus 1 can also change to s squared minus 1. It can also change to s squared minus 1 squared. This is another difference of 2 squared. Again, so this will give me x plus 1, x minus 1. So let's keep this one too. So let's put these two. Let's put these two. Let's put this and this in the equation. Now I have 2 brackets. This. So I will now end up having. Let's go. So I will now end up having 2 brackets. What do you get for my answer? Now what do you get for 1 cube minus s cube? Now we got this first thing. Let's call this one 1. It's not equation, so that don't be scared. It's not equation, 1 equation, so I just call it 1. So let me put 1 up. So that will give me 2 bracket 1 minus x bracket 1 plus x plus s squared divided by s squared plus 1, s squared plus that's untouchable, then divided by the second one that's factorizable, x plus 1, x minus 1. Now there's a little problem here. To start with, can I factorize this s squared plus x plus 1? I can't factorize that, because that will have be something like s squared plus x plus 1. Now product of plus 1, sum of plus 1. Can't factorize, so this will remain the way it is. The little problem here is that I'm going to rewrite 1 minus x. Don't forget that I can rewrite 1 minus x. 1 minus x can change to minus bracket x minus 1. I've explained something like this before. You can check example 7 or thereabouts. So 1 minus x will give us minus bracket x minus 1. If you expand it, you get the same thing back. So what I'll do is that I will change this question back. So this one will become minus 2 brackets 1 minus x is now what? X minus 1 bracket. This remain the way it is. 1 plus x plus s squared over, this is the way it is, s squared plus 1, s squared plus 1 bracket x plus 1, x minus 1. So there's a common factor now. Our common factor now is now this. This cancels this. So I'm left with what? Minus 2 brackets 1 plus x plus s squared divided by s squared plus 1 bracket x plus 1. So at this point I can simplify further again. So at this point I can substitute the value for x. What's our value for x? Our value for x is as x tends to 1. So let's substitute the value back. So that will give us minus 2 bracket 1 plus 1 plus 1 squared over 1 squared plus 1 bracket 1 plus 1. So all of this will give us minus 2, all of this will give us 3 over, all of this will give us 1 plus 1 is 2, another 2. So then I can cut this, can cancel this, so I'll be left with minus 3 over 2. So that solves that. Let's solve the last question, number 10. This is a question on limit to infinity. This was the second step I was talking about in the notes. When you have limit to infinity, I think I listed it last time. When you have limits to infinity, what you do is that, okay, instead of me going back, when you have limits to infinity, you, sorry, a minute, when you have, anytime you have limit to infinity, this limit to infinity, what you do is that you divide both sides, you divide all two by the power of the highest variable. So you divide all two, you divide all two by the highest power of the variable. Now what is the notes of the variable? So we have variable n here. So the highest power of the variable n here in this case is n cubed. So I'm going to divide everything by n cubed. So this will give me n cubed over n cubed plus 4n over n cubed minus 6 over n cubed over n cubed over n cubed plus 5n squared over n cubed plus 1 over n cubed. So in the long run, this we cancel this. I'll be left with 1. This we cancel one of this. I'll be left with 4 over n squared. This will remain the way it is. This is n cubed. This we cancel this. I have 1. This we cancel one of this. I have plus 5 over n. And this will remain the way it is. 1 over n cubed. N cubed. Now this infinity here, lim infinity here actually means undefined. Infinity actually means undefined. So at what point will I make all of this that have fraction to be undefined? At what point will I make all of this? This one touch now. This one has a fraction. Yes, that's a fraction. That's a fraction. That's a fraction. So at what point will I make these ones that have fraction to be undefined? It will be undefined when the denominator is 0. It will be undefined when the denominator is 0. So here we have 1 plus, so I saw to n as 0, 4 over 0 squared. At that point we undefined, so it will go over 6 over 0 cubed. At that point it will go to over 1 plus 5 over 0 plus 1 over 0. So that will mean that this will go, this will go, this will go, this will go. So I'll be left with 1 over 1. The answer is 1. So that was the end of our video on limits of function. See you in our next video where we are going to explain how to differentiate from first principle. Thank you for joining us.